Hello everyone. Today we are going to be looking at the IXL assignment F20 on solving equations using square roots. Okay, so this is what your assignment looks like. You've got you're solving for that unknown variable, but really you're finding the square root of that variable. And I'll show you exactly what I mean when we start doing some examples, okay? The first thing we want to look at, though, is we want to look at some important notes to keep in mind as we're solving equations using square roots. Okay, so perfect square is a whole number whose square root is going to be an integer. Okay, so perfect square would be like a number like 4. Okay, you find the square root of 4. Zoom this in a little bit. You find the square root of 4 and you would determine that 2 times 2 will give you 4. So we would say that 2 is the square root. Okay. Another example would be if you have the number 9. Okay, the number 9, we could say, okay, so 3 times 3 will give us 9. So we would say the square root of 9 is 3. Okay. One thing to keep in mind as you're going through finding the square roots is that squaring a number and taking the square root of a number are inverse operations. So when we look at this, we can say, okay, if I have a number that is, x squared, we'll leave it as that. In order to find the inverse operation of this, we would just find the square root of x. Okay, and the other way applies as well. If you have the square root of x, you can square that to get rid of the square root sign. Okay, because remember with solving for those variables, we want to get that variable by itself. So if we have x squared, that variable is not by itself. That's not solved. Okay, same thing with the square root sign. If we have that, then it's a situation where, you want to get that variable alone. So we square that to get it by itself. Another thing very important as far as this IXL assignment goes, and I'm going to repeat it as we're going through some of these examples, is a number is always going to have 2 square roots. One is going to be positive, okay, and one that is going to be negative. All right, the positive square root is also known as your principal square root. Okay, and then the negative square root is just known as the negative square root. So we've got the principal square root and the negative square root. This is going to be very important when you're completing this IXL assignment F20, because with this assignment, they're going to ask you for 2 square roots for the answer of every question. So you have to remember that you're always going to have that positive and that negative square root when you're solving. Let's go ahead and take a look at some examples from this assignment. So when we're solving this first equation, and I'll hide the rest of it so we're not looking at the other ones. Okay, so we want to solve for a in this equation. And when we're solving for a, we have a squared is equal to 4. So I'm just going to rewrite this and leave myself some space to the side. Okay, now remember when we talked just a second ago about inverse operations. Anytime you have this, you're squaring a number, the inverse operation is going to be to find the square root. Okay, so the inverse operation is going to be to find the square root of that. All right. So in this case, we're going to find the square root of both sides of this equation. And in the end, this is going to cancel as well as this, and we're just going to be left with a by itself. Now we want to look at that square root of 4. What number can be multiplied by itself to get us to that number 4? And we could say that, okay, so 2 times 2 will give us 4. So we could say that the square root of 4 will be 2. And this is where, when you go to answer, you're going to say, okay, a equals 2, or what is my other square root of this question? And that's where this is our principal square root. And we would also say that a is equal to negative 2, which is the negative square root. And if you don't believe this, try it out, test it out. Okay, so the original equation said a squared. So we could say, okay, so a squared, we would say is equal to 4. So we just want to check 2 squared. So 2 times 2, does it equal 4? And we would say, okay, so 2 times 2, yes, that's 4. But then what about if we're checking negative 2 squared? Okay, so negative 2 is squared is the same thing as saying negative 2 times negative 2. And remember those rules of integers. If you are multiplying two numbers that have the same sign, your answer will be positive. Okay, so two numbers with the same sign, negative 2 times negative 2, we will also get a positive 4. So it does work. So we could say that our answer for this is 2 or negative 2. Let's look at another one, another example of this. Okay, so we've got solve. We want to solve for r in this question. Okay, we're going to set this up the same way. We're going to say, and I'm going to leave myself some space to add those square root symbols. And I want to cancel this r squared. I want to cancel the squared. So I'm going to find the square root of both sides. This is going to cancel. And I'm left with just r equals. Now I got to think, okay, what number can I multiply by itself to get 81? Okay, and if you're thinking about it, we could say, okay, 9 times 9 will give us 81, which means that our square root of 81 is 9. So we want to find that number you can multiply by itself. Okay, or we could say 9 or negative 9. Okay, that would be our answer. Because if you say negative 9 times negative 9, you would also get an answer of 81. So this is our principal square root. And this is our negative square root. One thing I want to also say is you might come across this later on or in class sessions or in later assignments, but when you have a positive and a negative, so you have a positive 9 and a negative 9 as your answer choices, we could also say that r is equal to, and then we're going to draw this symbol, plus or minus 9, because the number is the same. Okay, now with this IXL assignment, you won't see that. You'll put them in separately, but just for future reference so that you can look back at this and say, oh, I've already seen that before. All right, let's look at another one. Okay, so this one we're solving for F. Okay, we still have this equation, and this number on the other side of the equal sign is okay. You're still going to solve it the same way. Okay, we're still going to take that inverse operation to cancel out the squared. We're going to find the square root of both sides. This will cancel, leaving us with just f equals. And then we want to think, okay, so what number can we multiply by itself to get to 121? Okay, this is going to be, we know it's going to be, if you're unsure about it, you can always think, okay, what's the square root of 100? And we could say, okay, the square root of 100 is 10. What about, so it's got to be higher than 10. So we could say, okay, what about 11? Okay, if we take 11 times 11, 1 times 1 is 1, 1 times 1 is 1, and then we're going to bring down our 0. 1 times 1 is 1. 1 times 1 is 1. And then we're going to add them together. Okay. 1 plus 0 is 1. 1 plus 1 is 2. And then bring down your 1. So we could say that, okay, the square root of 121 is 11. Okay. Now, when we go to put this into our IXL, we want to make sure we put that positive or that principal square root. And we also want to put that negative square root. You're always going to have two square roots with when you're having to square the number. Okay. What about this one? Okay, so this one, same setup. We're solving for A now. It's okay that the number is on the other side. So we got our number over here, and then we got our variable on the other side. Okay. So we're going to find the square root of both sides. This is going to cancel for us, leaving us with just A. And then when we think about what the square root of 144 is, we know that the square root of 121 was 11. So we can try a number higher than 11. Let's try 12. If we do 12 times 12, 2 times 2 is 4. 2 times 1 is 2. Bring down our 0. 1 times 2 is 2. 1 times 1 is 1. And then we are just going to add these together. This is going to be 4, this is going to be 4, and this is going to be 1. So we got 12 times 12 does give us an answer of 144. So we would say that the square root of 144 is 12. When we go to put this into IXL, we're going to say we have our positive 12, which is our principal square root. And then we're going to have our negative 12, which is our negative square root. So it's always going to be the same number. You're just going to have to put them in differently. And it does not matter if you put the negative 12 in the first place or in the second place. Okay. Let's look at some harder ones. So a little bit more challenging questions. So in this case, we want to solve for n, but we're going to do it the same exact way that we were doing the other questions. Okay. We're going to set this up as n squared equals 196. And we want to find the square root of both sides. We're solving this equation using square roots. So this is going to cancel. We're going to be left with n. And now we have to figure out, okay, so what's the square root of 196? We know that the square root of 144 was 12. So if we want to try, we could try 13. Okay, so 13 times 13. 3 times 3 is 9. 3 times 1 is 3. Bring down our 0. 1 times 3 is 3. 1 times 1 is 1. 1. 3 plus 3 is 6, and then 9. But that's not, it's close, but it's not quite there. So let's try 14. Let's go one more. 4 times 4 is 16. Carry our 1. 4 times 1 is 4 plus 5. Bring down our 0. 1 times 4 is 4. 1 times 1 is 1. And then we're just going to add them up and we get 196. So we could look at this and we could say, okay, the square root of 196 is 14. Okay, and it's okay if you have to try a couple. We tried 2 different numbers if you're using a calculator, okay? But if you're doing it on paper, you could try a couple numbers, and you can always kind of, you know, guess a number and then see how close you are. If you're too far over, you know, pick a smaller number. If you're too far under, pick a bigger number. So in this case, we've got n equals 14, which is our principal square root. And then we've got n is equal to negative 14, which is our negative square root. Okay. Let's try one more because this is fun. All right. So this is a much bigger number. Okay. We're solving for t, but we're going to do the same thing. So t squared is equal to 361. When we find that square root of t, we find the square root of the other side as well, but this is going to cancel for us, leaving us with t is equal to, and now we have to figure out what is the square root of 361. All right, so we know that the square root of 14 was 196. So we know it's going to be much higher than 14. A couple numbers higher than 14. We could probably look at this and say it's probably not going to be 15. So let's just go ahead and try 16. Okay. 6 times 6 is 36. Carry our 3. 6 times 1 is 6 plus 3 more is 9. Bring down our 0. 1 times 6 is 6. 1 times 1 is 1. And then we add. We bring down our 6. 9 plus 6 is 15. And we get to 56. Okay, so we know that that is not going to work. Looking at that too, we're still pretty far. So maybe we could actually go ahead and try, let's just skip to 18. Let's try 18. See how close this will bring us. 8 times 8 is 64. 8 times 8 is 1 plus 6 is 14. Bring down our 0. 1 times 8 is 8. 1 times 1 is 1. And then we add. Bring down our 4. 4 plus 8 is 12. And carry our 1. And we get 324. So you can see that we're getting much closer now. I would say that it'd probably be safe to just go to 19. That way we don't go too far over. Okay, so now we have 9 times 9 is 81. 9 times 1 is 9, plus 8 more is 17. Bring down our 0. 1 times 9 is 9. 1 times 1 is 1, and then we add. 1 plus 0 is 1. 9 plus 7 is 16. Carry our 1, and we get 361, which is perfect, which means that the square root of 361 is 19. So when we put this in, we're going to say t is equal to 19, which is our principal square root. And then t is also equal to negative 19, which is our negative square root, because if you multiply negative 19 times negative 19, you will also get a positive 361. All right. Well, thank you so much for watching this video.